Let us study the chapter Sound. A world without a sound can be imagined only with mixed feelings of horror and fun. The beautiful songs, the chirping of the birds would have been excited only in dreams. There would have been a lot of misunderstanding right from individual to nation, as no one could have been able to speak to somebody else. Sound is a form of energy that is produced by the sensation of hearing in our ears. When we clap, sound is produced. Can we produce sound without utilizing energy? No. In this chapter, we are going to study its physical aspects of sound, its production, propagation, and its role in daily life. Sound is produced whenever an object is set into vibrations of small amplitude. Vibrations means a kind of rapid to and fro motion. To understand the phenomenon of production of sound, let us understand with the following activity. In the activity 1, take a metallic bowl and a spoon, place a bowl on the table, and then hit it with a spoon. We will hear a sound. And now touch the bowl gently with the finger, we will feel vibrations. In the activity 2, take a glass and fill it with water till its brim, and bring a vibrating tuning fork and dip one of its prong inside the water. We will observe vibrations in the tuning fork as the water will spill out of the beaker. Water will not move unless the vibrations are there. So sound cannot travel in vacuum. Sound is a mechanical wave which needs medium to travel. Let us study the characteristics of sound wave. Sound travel in the form of longitudinal waves having compressions and rarefactions. At compressions, the density of the medium increases as the particles are crowded together. It is represented by the upper portion of the curve. The peak shown in the graph represents the maximum compression. At compression, the density as well as the pressure is both maximum. Rarefactions are represented by letter R, and where the particles of the medium are spread apart and the density as well as the pressure here is very less. And here it represents the valley, that is the lower portion of the curve. Now let us study the characteristics of the sound wave. First characteristic of sound wave is frequency. Number of oscillations produced per second is called frequency. Its unit is hertz and it is denoted by letter nu. Frequency tells us how many times an event occurs per unit time. Suppose we are hitting a drum with a stick 10 times in 1 second, then the frequency of the beating drum will be 10 hertz. The wave velocity, the wave density of the medium oscillates between maximum and minimum value. The way our brain interprets the frequency of the emitted sound is called pitch. The pitch depends upon frequency. The more the frequency, more will be the pitch. Second characteristic of sound wave is wavelength. It is defined as the distance between two consecutive compressions or rarefactions, or we can say the between two crust or trough, between the crust and the trough is called wavelength. It is represented by letter lambda and it's measured in meters. The third characteristic of the sound wave is amplitude. Maximum displacement of an object from its mean position is called amplitude. Or also we can say the maximum displacement of vibrating particle from either side of its mean position is called amplitude. It is represented by letter A. Its unit is meters. The loudness and the softness of the sound depends upon amplitude. When we apply force on the object, it vibrates. If the applied force is larger, the amplitude will also be larger. Its amplitude force is low, the faint sound will be produced. Next characteristic is time period. Time taken by the wave to complete one oscillation, or we can say the time taken by the wave to travel at a distance equal to one wavelength is called time period. It is represented by letter T and its unit is seconds. The next characteristic is velocity. Velocity is also called the wave velocity. The more the velocity of the propagation of the wave is called wave velocity. It is represented by letter V and its unit is meters. Laws of reflection of sound. Sound bounces off a solid or a liquid like a rubber ball bounces off a wall. Like light, sounds gets reflected at a surface of a solid or a liquid and follows the same laws as the reflection of light. There are two laws of reflection of sound. The first law of reflection of sound states that incident wave, reflected wave and the normal at the point of incidence all lie in the same plane. The second law of reflection of sound states that angle of incidence of the sound is always equals to angle of reflection of sound. Range of hearing of sound. The range of frequency to which our ear is sensitive is called audible range. For humans, the audible range is 20 Hertz to 20,000 Hertz. As we grow old, our audible range becomes shorter. The upper limit of the frequency is much higher in children than in the older people. Infrasonic sound is the sound with the frequency which is less than 20 Hertz, like of whales, elephants and rhinoceros. Sound with frequency more than 20,000 Hertz is called ultrasonic sound. It is produced by creatures like bats, dogs, birds and insects. Factors affecting sound. The factors affecting sound are like medium. Sound travels faster in denser than in the rarer medium. It cannot travel through a vacuum. It needs a medium to travel. Temperature. Speed of sound increases with the increase in temperature. Quality of sound depends upon pitch and the loudness of the sound. Uses of multiple reflection of sound. Megaphones or loud hailers, horns, musical instruments such as trumpets and shehnai are all designed to send sound in a particular direction without spreading it in all the directions. In this instrument, a tube followed by conical opening reflects sound to guide most of the sound waves from the source in the forward direction towards the audience. Stethoscope is a medical instrument used for listening to sounds produced within the body, chiefly in the heart or lungs. In stethoscope, the sound of the patient's heartbeat reaches the doctor's ears by multiple reflection of sound. Generally, the ceilings of the concert halls, conference halls, and cinema halls are curved so that sound after reflection reaches to all the corners of the hall. Sometimes a curved soundboard may be placed behind the stage so that the sound after reflecting from the soundboard spreads evenly across the width of the hall. Reflection of sound is also used by bats to catch its prey, and it is also used in sonar. We are going to study the structure of human ear. Ear is a very sensitive device which God has given us. When sound is created, it produces pressure variations in the air which travel to the brain through auditory nerve. The outer part of the ear is called pinna. The main function of the pinna is to collect sound from the surrounding. The collected sound passes through the auditory canal and reaches to the eardrum. Eardrum is a thin membrane which is also called tympanic membrane. We know that propagation of sound is through compressions and rarefactions. When compressions reaches eardrum, the pressure outside it increases, resulting in inward push of the eardrum. And when rarefactions reaches the eardrum, it results in outward push of the eardrum. Thus, membrane of the eardrum starts vibrating. The amplitude of the vibration is amplified several times with the help of three bones: hammer, anvil, and stirrup in the middle ear. Middle ear transmits these amplified pressure variations into the inner ear. These pressure variations are then converted into electrical signals by cochlea in the inner ear. These electrical signals are sent to the brain by auditory nerve and interprets them as sound. Now, let us recapitulate the structure of human ear with the help of flow chart. Vibrations from the outer ear, from the outside, are collected by outer ear called pinna. Then it goes to auditory canal and vibrates eardrum. And then these vibrations goes to middle ear. And with the help of three bones, it gets amplified, and these amplified vibrations goes to inner ear, where they are converted into electrical signals by cochlea and are then sent to brain through auditory nerve.